Okay, cool. Hello, everyone, and thanks for joining me for this talk about demystifying the test pyramid. Before everything, let me introduce myself. My name is Xavier Gouchet. I'm a senior software engineer at Datadog. I've been working on Android for the past 12 years, and testing is one of my favorite subjects to talk about. If you don't know about it, Datadog is an observability platform allowing you to track logs, status, and performance metrics across all your organizations and applications. We provide over 600 integrations, including Android, iOS, Flutter, and React Native. We also have a new feature that's going to come pretty soon where you can have mobile testing inside the UI, UI mobile testing inside your browser directly, providing even more feature for mobile developers. Anyway, we're going to talk about the test pyramid, and just before we start, can we have a show of hands of anyone who have already heard about or used the test pyramid here? Okay, cool. So we're going to revisit the origin of the test pyramid, and then we're going to see in this talk how we can have a more modern vision of what it is and how we can use it in a project. So the test pyramid started in a book written in 2009 by Cohn called Succeeding with Agile. And in this book, there is a whole chapter around automated testing. And in this chapter, Cohn writes that an effective test automation strategy calls for automating tests at 3 different levels. And this is the place where he starts drawing this iconic test pyramid diagram that we all know about. And then he says, if the automated test suite is growing daily and has run without error every night of the sprint, the team is probably in good shape. And this is basically the heart of this chapter about automated testing. This is the original drawing of the test pyramid. I'm sure everyone that's raised their hand must have seen one version of it. And mostly, this says that when you have automated testing, you have basically 3 different layers of testing. The first layer is going to be the unit. In the unit layer, you're going to do unit test, and the unit test is basically trying to write a test across a single unit of work. So it could be just a method, it could be a class, it could be a package. It's any part of your code that can be tested independently from the rest. So usually, it's going to be fast and reliable in CI. We're going to use lots of mocks. But one of the drawbacks is that more often than not, you're going to have a tight coupling between the unit test and the actual implementation of the feature of the unit that you're testing. Then we have the service layer, which is basically what we can call integration test. The service layer is where you're going to take a couple of units, 3 more, and try to test them working together. So testing 2 or more units interacting together is going to allow you to validate the integration before we get to the end-to-end test. We're still going to have some mock, mostly for the network and the database, because we want to have reliable tests. And the network can be flaky, the database may be corrupted, so we try to get away from all this flakiness. But the good thing with this is that we start putting all the things that we built together and make them work together. The problem with this is that it's more often than not is not exhaustive, and when there is an issue in the test, it's harder to find where it comes from. When you have an issue, when you have a test failing in unit test, it's pretty easy to know where the issue comes from. When you're in the integration layer, it can be a bit harder. Finally, we have the UI testing, where basically this is the end-to-end test. So you're trying to view your application under test has in the same way that your users would. So you're testing the whole product from the outside with no assumption of how it's built. You just want to validate that it works as intended from an outside point of view. So it's going to validate the user experience, but you're going to have a lot of fragility and flakiness because you're going to rely on a network, you're going to rely on the actual database that is in production, and you're going to have a lot of moving parts that might break at some point, meaning that it's even harder to debug when a UI test fails. One of the things is that why do we have the integration and end-to-end test? Mostly because when you have unit test, it means that, yes, this piece of the code works perfectly. And then you take another unit and this other part of the code works perfectly. But when you put them together, it doesn't work. One of the reasons that we have this is mostly because of the mocks. Because when you're writing a unit test, The feature that you're testing is not just living in its own world. It still needs to interact with the rest of your code. And because you want to test just a unit, you're using mocks to make a simulation of what the outside of the unit behaves. The problem is that nothing ensures that your mocks are actually behaving the same way that the real implementation is going to behave. Meaning that you can have your mocks that you write for your test go green, but then when you're using the actual implementation, the actual implementation is not going to work like the mock, and your tests are going to fail. So this is why the integration test is very, very important. So what's up with the test pyramid? First of all, this is an old model, but it's very good because it started popularizing the idea of automated test. Back in 2008, 2009, it wasn't very obvious that you needed to have a CI that runs tests every night or every time you have a new commit pushed to your dev branch. Meaning that it helped people start using CI, start making tests, start writing tests. And it all went better from then on. But the problem is that, like all popular things, it was taken at face value. So people just took the diagram of the triangle with the 3 layers and say, oh, this is what we need to do exactly, and didn't think further than that. And the problem is that it gives the wrong idea that the volume is important. More often than not, I've heard engineers say to me, oh yeah, you need to have 60% of unit tests and 30% of integration tests and 10% of end-to-end tests, which is roughly what the areas in the original pyramid is. But the problem is that that's not always the case. The main thing is that those volumes were driven mostly by the cost of writing the tests, running them, and maintaining them. Of course, it's much harder to run an end-to-end test than running unit tests. The unit tests are usually very, very fast. You can run them on the JVM, whereas end-to-end tests, you're going to need an emulator or a real device, which is not as easy to set up. But it doesn't mean that you need to have more unit tests. And also, writing unit tests is often easier because you're just working with a simple unit, which is easier to set up. When you're writing an end-to-end test, you're going to have a lot more to set up. Other thing is that the test pyramid, as it is, does not always match all types of projects. Some projects might need more end-to-end tests. Some projects might need much more unit tests. So it's not a one-size-fits-all situation. Finally, the main thing that I don't like about the test pyramid is that it's not a pyramid. It's a triangle. So we're going to revisit that. But one of the things, so the triangle is easy to understand, but it lacks nuances. So this is one we're going to look at. One of the quote that I really like by George Box is that all models are approximation. Essentially, all models are wrong, but some are useful. So we're going to see what's useful about the test pyramid, and we're going to look at how we can improve it. So I'm not the first person to revisit the test pyramid. There's been a lot of blog posts, a lot of articles about that. We're going to see some of them, and we're going to see what we can take out of this. The first thing that I really like is this sketch that was drawn by Noah Sussman back in 2017. And basically, he started looking at the test pyramid in an upside-down way. Basically, a test pyramid upside down becomes a sieve that tries to filter all the bugs that you can think of. So at the top, you're going to sprinkle all your bugs. And every layer of your test pyramid is basically trying to filter and remove some of the bugs. So the first layer is the unit test. You're going to have a lot of those. And those are going to be able to catch all the big bugs, the one that's easy. Like, oh, you're trying to put a negative number. No, we can't do that. Oh, you're trying to put a null value. You can't do that. Those are very easy to do. But some bugs are going to pass through the cracks, through the sieve, and go to the next layer. You're going to have the integration layer where you're going to find more bugs. Those are going to be less obvious, but you're still going to be able to catch them. And some are still going to come through to the end-to-end test. And then you're going to still be able to find some of those more related to the UI and the UX, but you're still going to be able to find some. And eventually, maybe some of those are going to fall down to the human layer, so human testing. So if you're lucky, those bugs are going to be found by your QA team, which are going to test the application with the phone in their hands. If you're not lucky, it's going to be found by some of your customers who are going to put a bad review on the Play Store. So this is, I think, a very good way of thinking of tests, because this is basically the sieve that tries to filter all the bugs that you can think of, and the goal is that your test must be as tight as possible to find all of those. Another thing that I really liked was in a book called More Agile Testing, wrote by Lisa Crispin and Janet Gregory in 2014. And there is this quote by Sharon Robson that talks about the test pyramid, where she says, I interpret the Agile testing pyramid as a beginning to a discussion about test strategy in an Agile team. And if you only remember one thing from this talk, this is it. Basically, the test pyramid, whichever model you think of about the test pyramid is and should be the beginning of a discussion of what should the test be in this team? What should the test be? What should the test look like in this company? And then Sharon Robson goes on into kind of the same idea that I had, which is that a pyramid is a self-supporting structure that cannot exist without each of its sides. Each has a different focus or direction, but each ties into the whole unit. So basically, it's the same idea. The original test pyramid is just a triangle. We need more sides to it. So she starts trying to think about what those sides can be, and this gave me most of the ideas that I'm going to explain then in the talk. So a pyramid is going to have 4 sides. And basically, all of the sides are going to start to answer to 4 basic questions that you need to have about your tests. The first thing is, what are we testing? This is the first side of the pyramid, and basically this is the one that we already know about. The second thing is, how are we testing it? The third thing is, why are we testing? More importantly, usually when we are writing tests, we try to build our confidence about something. So what are we looking to gain more confidence on with those tests? Then the main question is, when are we running the tests and where? So we're going to look at the pyramid and answer all of those questions on each of the sides. So the first side, as I said, is what? What are we testing? This is an example of a pyramid. It's not a silver bullet, so obviously it's not taken to be taken at face value, but it's an example to show you what I mean. So at the base of the pyramid, I'm putting static analysis. Static analysis is basically trying to analyze and test the code itself. So are you trying to have a good syntax, preventing code smells, preventing bugs that arise just from the language itself? The layer above is trying to look at the units. So we're going to have the unit test like we have, taking each piece of your code on its own, independently from the rest, and making sure that each one of them works as expected. Then we're going to have an integration test, putting pieces together, but removing all the flaky part, network, database, and all that. And finally, having the end-to-end test just to ensure that the whole thing, as a whole, from the user point of view, works perfectly. So that's pretty good, but we need to remember that the level size don't relate to the number of tests we need to write, the importance of those tests, and the speed of those tests, right? All those questions are different for each of the layers, and depending on your projects, you're going to have more integration tests or more end-to-end tests or more static analysis. Also, I added 4 levels, but you can have more than that, you can have fewer than that, depending on your projects. For instance, you can have more level for the business rules, you can have more level for the APIs or the data format, you can have more level for the security, and so on. So that's the first side of pyramid, answering the question, what are we testing? The next question is, why are we testing things? Why do we want to write tests in the first place? Well, for each level, we might have a different answer. For instance, when we're writing static analysis tools, what we want to check is having more confidence in the quality. On the maintenance, if you're using syntax checks, you're making sure that basically every engineer working on the same code base can understand every file and doesn't have to adapt to, on this file I'm having 4 spaces for the indentation, and on this one I have 8 spaces, and on this one I have, 7. So having the same syntax everywhere, make sure that it's more maintainable. Having code quality tools allow you to make sure that you don't have code smells and that your code is following the standards on the language. So if you're using Java, you're following Java standards. If you're using Kotlin, you're following Kotlin standards. On the next level, unit tests, you're trying to make sure that you have confidence on reliability and the performance. So at the unit level, you can make sure that each part of your code is very performant and that it works as expected. So you can rely on the functions doing what they should be doing. The level above that, integration test, we're trying to test functionality. So making sure that all the pieces together work correctly. And at the end-to-end test, we're trying to mostly focus on the usability, making sure that the product itself is usable. One of the things that I really like is that when you're writing end-to-end test, basically you have to do all the steps that a customer would do with your application. So if writing an end-to-end test to do a specific features requires you to go through 5 screens, tapping 20 buttons, you can think, oh, doing this operation from a user point of view is a bit tedious. Maybe we should improve the UX. So why are we testing? There's not just all those answers. There are lots of reasons why we might want to write tests. We want to verify that the code works, TM. We want to make the contract explicit. We want to guide the development. If you're writing with TDD, and you should. We can prevent regression that might be caused by other devs that might not know this part of the code, or just ourselves in the future because we don't remember why we did this. And ensure the retrocompatibility. And the list goes on. Like, it's not exhaustive. There are lots of reasons why we might want to write tests. The third side of the pyramid is answering the question how. And this is a great one because this is the question of which tools are we going to use. So those are going to be just examples because there are dozens and dozens of tools nowadays to write tests and at each of the level. And so basically, there's no good and bad answer. It's just the one that's right for your project. So for the code quality, for the static analysis, you can use detect, you can use Kitalint. For the unit test, you can use JUnit or Spec or any other things. For the functionality, you can use JUnit or Espresso. And for the usability end-to-end test, you can use Datadog or Maestro. And basically, those are just some of the tools. The main thing is that you need to ask yourself the question, which tool is the best for the test that we're writing and for what we want to get out of those tests. So maybe, the ease of using the tool is a good question. The ease of running them in CI is a good question. And the ease of what you can get out of it, which features are allowed by all of those tools, is the very, very good question. So basically, the thing is that try to use all the tools. There are, of course, the obvious ones that are the standards. When you're going to start writing Android code, you're going to use detect and JUnit and so on. But maybe those are not the right tools for your team or for your project. And there are new tools coming out every month anyway, so new projects are coming in. Some projects are not maintained anymore. So keep yourself up to date with different tools that exist and maybe try changing them and see what they can bring to your project. The fourth side of the pyramid is when are we running the test? The good answer is all the time, but more specifically, each of the layers might be run more often than the others. For instance, and this is again just an example, but for the static analysis, maybe the tests are going to be run every commit. Because static analysis is usually something that comes very fast. So just the compilation is a test in its own. And a detect or a Kitalint pass is very, very fast. So usually what I do is I put them in a hook in Git. You can say, oh, before I do a commit, I'm going to do a hook that's going to do a pass on detect and Kitalint just to make sure that the thing that I'm committing is correct for regarding the syntax and the code smell quality. Then for the unit test, you might want to have something running for each commit or for each PR. For the integration test, you won't want to have something running for each PR or each pull request or every night. And for the end-to-end test, you might want to have some, because those are more costly usually. You want to run them every night or for each releases or for each milestones. Those are just examples. The main thing that you need to remember is that you need to make them available as well for local development, meaning that the setup for the environment must be reproducible on any laptop of every engineer in the team. So if your end-to-end test can be run from a local development and can only be run on the CI, you have an issue. because when a test fails, it's going to be very tedious to find why the test failed, because you want to usually run the test with a debug mode, with breakpoints, and if you can't do that locally, you're going to lose a lot of time. Also, it must be easy to run locally. So usually when you have your contributing guides or your documentation for onboarding, you need to have a section that says, oh, by the way, this is how you run each test locally on your developer machine, and it needs to work exactly the same as it would in CI. Talking about CI, it's like the tools, we have a lot of choice. You can go with the CI provided by your VCS, so you can use GitHub Actions, GitLab pipelines, or whatever is available with the company that hosts your repository. You can use some third-party vendors. You have Bitrise, Circle CI, Travis, and so on. And you have, of course, the custom hosted one. You can use Jenkins and similar situation. The main goal is make sure that it's always reproducible locally so that when you need to, you can run them from your own laptop. About test rules. So this is going further in the question about why we're testing. This section was inspired by a blog post by John Ferguson Smart back in 2017, where he was talking about the test pyramid. And one of the sections is very interesting because it says that different tests also play different roles in the project. The traditional role of automated tests is to check that an application behaves correctly. However, tests can also play a role as living documentation. And then he goes on explaining that there are 3 different types of tests: tests that discover, tests that demonstrate, and tests that describe. And basically, on every level of the test pyramid, which we can have all the 3 types of tests. So first of all, you have the test that discover. Discover is basically trying to find out what my feature is going to be, how it's going to be used, and what I can do with it. So it's usually example-based. You're going to write a feature. You're starting from a product briefing that says, oh, this is a feature that we want to have, and for example, the user is going to do this and that, and this is what's going to happen. So you have you don't know exactly what the implementation is going to be exactly, but you have some examples. So you can use that to drive what your development is going to be. So it's basically the idea behind TDD and BDD. TDD and BDD, you're going to write the test first, and you're going to say, okay, this is how my unit is going to work, or this is how my feature is going to work on an integration level, and I'm going to just try to make it work top-down. So this helps discover the shape of a feature, especially in terms of API, interfaces, signatures, and so on. Then you have the test that describe. And this is what we mean when we say living documentation. Because the tests are going to be running all the time. In general, for every pull request or every night, your tests are going to run all the time against your implementation, meaning that the tests describe what your code is doing or should be doing. So it makes the contract explicit. This means that when you're not sure what your feature is exactly, you're coming to a legacy code base. If you can look at the code, you're going to see that, oh, my test is expecting this output when I put this input, so this is what I should be doing. It also can explain the business rules or the domain logic. So, for instance, you can say, oh, my user can put just up to 7 objects in their cart, and you're going to have a test that says, okay, when I put 7 objects in my cart, I'm going to be okay. If I put 8, I'm going to have an error, or I'm going to throw an exception, or I'm going to have something written in the logs. And this is what we meant by living documentation, because more often than not, the actual documentation that we need to write in Confluence or in Markdown or in Google Docs or anything is going to be out of date pretty quickly. Especially if you're writing something that's going to be in multiple modules where you have different APIs, you're going to have some documentation somewhere that says, oh, this is how we do things and this is how we write that. The problem is that more often than not, we don't update the documentation every time we do a pull request. So the only documentation that is always up to date and that is always right is going to be the one that lives inside your tests. The last type of test that we have is the test that demonstrate. And this is more tests that are there to illustrate some specific edge cases. So it's for complex or global scenarios or stuff that's, can be a bit weird. It's usually going to be detail-oriented, so this is tests that are specific to a very specific situation. And like I said, around edge cases. One of the rule of thumb that you have is whenever you have a bug that you find in your project, whether it's a bug that's reported by your customer through the Play Store, through a support ticket, or just through QA, and you say, oh, it's weird. When I'm putting my phone in landscape mode, then I navigate, and then I come back, the screen is blank. Well, this is a very specific scenario. Whenever you find a bug, you need to write a test that illustrates the bug before you fix it. Because you need to remember that, oh, this is a scenario that exists, that someone did at some point, and they found a bug. So in one of the first slides, when I talked about the integration and end-to-end test, we thought that they're not exhaustive. You can't test every situation that could happen in a word. But whenever you meet a specific case that doesn't work and make your application break or your feature break, you need to write a test to demonstrate that this is a scenario that can happen, and we want to make sure that we are ready for it. The last section that I want to talk about is about code coverage. Just show of hand, who here has heard about code coverage regarding tests? Cool. So code coverage basically is this idea that you want to know how much of your code is being covered by your tests. And in my mind, there are two different directions where this could go. Basically, we have the coverage for the feature compliance, which is on the x-axis, and on the y-axis, we have the coverage of the input coverage, which is basically you want to go on the top right direction. So you want to make sure that you're covering as much of the feature as you can, and you want to cover as much of the different inputs as you can. So when you think about the compiler or static analysis, you're not covering much, right? You're just testing that the code is working, all the types are correct, that you're following syntax, so you're not really testing anything. It's good for maintenance, but in terms of feature compliance or input coverage, you're not there. And then you're going to have unit tests, where you're going to have more information about the input coverage or about the feature compliance. The integration test and end-to-end tests are going to drive you even more further towards the feature compliance. But like we say, end-to-end tests can be exhaustive. Just to give you an example, in a company that I worked a few years before, we had a lot of different types of users because the company had partnerships with lots of operators around the world. So basically, we had like thousands of different types of accounts. We didn't have just free and paying and premium pro and so on. We had like 1,000 different types. So we couldn't run the end-to-end test for all those different type of users. So in terms of feature, we try to go towards the trying to cover most of the features, but for the input coverage, we couldn't cover all the types of user. And then we have the monkey testing, which is on the far left, but very, very high on the input coverage. Monkey test is basically this feature where you can say, oh, I'm going to run random taps on the screen and random inputs that's going to try to do crazy things with your application in your device, but doesn't know anything about the feature. So just to make sure that, yeah, I'm going to rotate the screen and tap everywhere and make sure that the application doesn't crash. And then you have something that's called fuzzy testing and property-based testing. If you've never heard about it, I really, really invite you to take a look at that. Basically, the idea is trying to use random or pseudo-random input to drive the content of your test. This needs a shift in the mindset, so it's a bit harder to write tests that are going to use that, but this can help you have much, much more coverage in terms of inputs while also staying true to testing the feature compliance. And the good thing is that fuzzy testing and property-based testing can be used both for all the unit test, integration test, and end-to-end test. So you can use that everywhere and try to have a better coverage of your input. Just to keep talking about coverage, some of you might have seen this. Basically, this has been tweeted a while back, where you have this success 26 on 26 test passed. So all the tests are green, meaning that the coverage is perfect, but you're not sure that actually it's actually testing something. The code coverage, when you just took a look at the metric, is basically telling you, it's based on the JVM. It's telling you that this function or this line of code has been visited during one of the tests. but it doesn't tell you that it has actually been tested. It just tells you, oh, while I was running the test, at some point, someone called this line. And that's it. That's all you know about code coverage. So a lot of people think that, oh, yeah, the code coverage report says 80%, so 80% of my test is covered. No, that's not true. One of the things that I really hate about code coverage is that it can become a target, an objective. I was once in a company where they say, oh, you need to get to, so we started from 0. And the CDO say, oh, yeah, you need to get to 20% code coverage for all of the projects by the end of the year. And if you do, you're going to have a bonus. We got the bonus. But we didn't write as much tests as we should have. Basically, making sure that all the methods are called on a JVM project is very, very, very easy. Just using reflection, you can do something that says, oh yeah, I'm going to look at all the classes that I can see, all the methods, I'm going to call everything. I'm going to have, like, we reach like 80% very, very easy with just a simple method. But yeah, this was not the way to go, but we got the bonus. So the more any quantitative indicator is used for decision making, the more subject it will be to corruption pressure. Basically trying to say, oh, we need to get to 80% coverage or 90% coverage or 99% coverage is not an objective. The objective is trying to make sure that, yes, we trust that the test is our safeguards. We are confident in our test and confident in the code that is tested. One of the things that you need to remind yourself is that when code coverage is at 80%, it doesn't mean that 80% of the code is tested. It just means that at least 20% of the code is not tested. So basically, code coverage is there to show you, oh, there's a gap in your test here. It doesn't tell you, yeah, this is tested. It just says, we are 100% sure that this part is not tested at all. So, wrapping up this talk, the first thing is that test pyramid is more what you call a template than actual rules. Meaning that, like Sharon Robson said, the test pyramid, whether you're looking at the Cohn version from 2009 or the one that I showed here, is the beginning of a discussion. You need to come to your team and say, okay, what do we expect to get out of the tests? Which one should we be doing? Which tools should we be doing? And when should they be running in the CI and on the local laptops? You don't need to have 4 levels exactly, right? You can have just 2, you can have 3, you can have 7, depending on what your project is. You can have as many tests as you can for each level. It doesn't mean that something is at the lower level of the pyramid that you need more tests. It's just a model. It doesn't mean, oh, yeah, we're not going to add an end-to-end test because otherwise we'd have more end-to-end tests than unit test. If you have a reason to write another end-to-end test, just write it. Discuss the pyramid regularly, right? As we saw, the test pyramid's first draft started in 2009, and there's been a lot of articles and blog posts since, and everyone has an opinion on it, right? And even when you're just talking about unit tests, when you're talking about mocking, or when you're talking about specific tools, everyone is going to have their opinion. So bring the discussion to the team and bring it regularly just to make sure that, okay, this is how we do things. Maybe this is not the best because some of the steps in the way we're writing tests is too tedious, or it's not helping, or it's not providing any value. So discussing it regularly makes sure that everyone still knows what the reason, why we're writing tests and why we're doing it this way in this team. Especially anytime you have someone that onboards on your team, try to explain that to them. You can and you should have conventions for tests. Best thing is if you have a contributing guide that says, oh, this is the kind of conventions for the team. This is how we write code. This is how we write Android applications in the team. This document that you should have for the onboarding of newcomers in your team should have a section that says, this is also how we're writing tests in here, this is why we're writing tests, and this is what we want to get out of it. One other thing, you need to be as confident in the test that you code as you are in the code you test. Thanks a lot, everyone, for listening to me, and if you have any question, I think we have a few minutes for that as well. Thanks a lot.